So in this class, we'll be treating electric field. What is an electric field? An electric field is a region in space where a test charge experiences an electric force. When we are talking about electric force, this force can either be a force of attraction or force of repulsion, and that leads us to the Coulomb's law. The Coulomb's law. Now, the Coulomb's law is the law that actually shows the relationship between the force of attraction or repulsion between two bodies and a distance apart between the bodies. Now, it states that the force of attraction between two bodies is directly proportional to the product of the charges and inversely proportional to the square of the distance between the 2 point charges. Now, the magnitude of the smallest charge ever measured is denoted by E, and that is called the quantum of charge. And we say a charge is numerically equivalent to 1.6 times 10 to the power of minus 19 Coulomb. 1.6 times 10 to the power of minus 19 Coulomb. So we have our Fe, which is the force of the electric force, to be equals to kq q prime over r squared. And we say our k is numerically equivalent to 1 over 4 pi epsilon naught. The epsilon naught is called the permittivity of free space, and is numerically equivalent to 8.84 times 10 to the power of minus 12 Coulomb square per Newton meter square. Now our k itself is 9.0 times 10 to the power of 9, and the unit is going to be the inverse of the unit of the epsilon naught. That would be Newton meter square per Coulomb square. That would be the inverse of that of the epsilon naught. The epsilon naught is c square Newton per meter squared. So option B is the correct answer. 4.375 times 10 to the power of 14. Now to the next question. We are asked to find the electric charge in 5 times 10 power 14 protons. Now this time around, we are not asked to find how many protons we have in a charge. We are asked to find the charge that 5 times 10 power 14 proton actually a mass constitutes. So how do we solve that? We have N already given us 5 times 10 power 14 protons. And don't forget, the formula is Q. So the answer is 8 times 10 power minus 5 coulombs, which is option C. Now to the next question. A force of 500 Newton exists between two identical point charges separated by a distance of 40 cm. Calculate the magnitude of the 2 point charges. Now the question clarifies that the charges are identical. Now when you hear the word identical, it means they are of the same type, they are of the same size, and they are of the same sign. You can see identical point charges. Now they are being separated by a 40 centimeters distance, and we are asked to calculate the magnitude of the 2 point charges. Now if you are asked to actually tell if what we have here is a force of attraction or repulsion, because you are already being told that the charges they are identical, it means they have the same signs. So it shows that what you'll be having there is a force of repulsion, not attraction, because they are identical in all aspects, including the sign and also in magnitude. But then we are asked to find the force of attraction. Now from the formula we had earlier on, we say the force of attraction between two charges according to Coulomb's law gives us this 9.43 times 10 to the power of minus 5 Coulomb, and that is option B. So we have this question. In the Bohr's model of the hydrogen atom, an electron E cycles the proton plus E in an orbit. If the radius is 5.3 times 10 to the power of minus 11 meters, find the force of attraction between the two particles. First, we know that we have the hydrogen atom, and in an atom, we are expected to have both the protons and electrons cohabiting, and that is why an atom is always electrically neutral. because we are always having the equal amount of protons and electrons, until when such atom undergoes reaction where it either gains an electron or gives out an electron. That is when it becomes either positively charged, that's as in the case of when it loses an electron, or negatively charged when it gains an electron. So we are asked to find the force of attraction between the two particles since they are of opposite charges. So how do we go about that? We have our F to be equals to KQQ prime (10 power minus 8 Newton), and that is option B, 8.2 times 10 power minus 8 Newton. That is the force of attraction between those two particles. Now, the second question here says we should find the electron speed. We are asked to find the electron speed. You know, in an atom, an electron is not a stationary particle. Electron is always orbiting around the shell. It is always moving. So you are now asked to find the speed of that electron. How fast is that electron moving? For you to get how fast the electron is moving, you need to use another equation that relates to this Coulomb's law. From the Coulomb's law, there is no parameter as the speed. But then don't forget that from the question, you are given another parameter, which is the mass of the electron. The mass of the electron is given as 9.1 times 10 power 31 kilogram. Now, what formula can you relate to this formula to give you the speed of that electron? Don't forget that this is force, and the force is equals to this. What other formula for force do you know that we can equate to this to give us to calculate our speed? We can use centripetal force. Our centripetal force, which is denoted as Fc, is equivalent to mv squared over r. You have 2.18 times 10 to the power of 6 meters per second. So that should be option C. It has 2.2. 2.18 is approximately 2.2 times 10 power 6 meters per second. Now the next question. A metal sphere has 4.3 times 10 power 21 protons and 6.8 times 10 power 21 electrons. What is the net electric charge on that material? Okay, so let's move to the next question. Two metals are separated by a distance of 2 meters in a water bath. If the force experienced is 5 newtons, what is the magnitude of the charge on each metal if the charges are identical, and we are given the dielectric constant of the water to be 80? Now, how do we go about this? Dielectric constant is given in this question. From our Coulomb's law, we have our F to be equals to K. So the answer is 0.422 microcoulomb. That's option D. To the next question. So we should have 28.8 newtons. So 28.8 newtons is the force that is experienced between those 2 point charges. So to the next question. The electric force between 2 point charges with a magnitude of 800 nanocoulombs and 900 nanocoulombs is 15 newton. How far apart are the two charges from each other? Now, if you look at the options there, they are expressed in centimeters. So by the time you get your answers, it will be in Newton. So you have to convert back to centimeters. So we have 800 nanocoulombs. That's 800 times 10 power minus 9 coulomb, and you have 900 times 10 power minus 9 coulomb. That's Q and Q prime. And you have your force to be equals to 15 newton. So you have to find the distance apart. So you have your F to be equals to KQQ prime. That will give us 2.08 centimeters, which is approximately 2.1 centimeters. So that is option B. So the next question. Now, this particular type of question is a bit dicey. Now, when you see questions like this, you have to be very, very careful. It is also under Coulomb's law. But then, instead of having charges that are parallel to each, Answer is going to be 0.142 microcoulombs. So that is the answer to this problem. So we have come to the end of this video. Drop your questions and comments in the comment section below. I'll see you in my next video. Thanks for watching. We'll be treating electric field. I'll be using a question-based approach to tackle this problem so that you get familiar with the number of questions that is possible you find on your screen during test and examination. So let's start. A region in space where a test charge experiences a force of electricity is called what? What do you call a region of space where an electric force is likely to be experienced? That particular type of space is called an electric field. Why is it an electric field? The conventional direction of electric field is what? What is the conventional direction of electric field? Earlier we said we use lines of force to represent electricity in the electric field. Now we are now asked to show the conventional direction of electric field. Now, if this is a test charge, let's say this is test charge A and this is test charge B. It migrates from the positive into the negative. So that is it. Option C, that is electric field originates at the positive charge. The next question, electric field terminates at where? That is when your electric field originates. Okay. Now what happens when one material is rubbed against another? What happens when you rub one material against another? What happens is actually that. So the best answer to go for it is that the materials become electrically charged. When you say electrically charged, it encompasses both negative and positive charges. So option C is the correct answer. The material becomes electrically charged. The insulance between the two plates of a capacitor is called a what? So our dielectric is the correct answer to this question.